From communications to the expansion of our species, space is critical to the future of humanity. But getting there is expensive. Even using the most cost-effective launch vehicles on the market, the cost of getting to orbit is about $1,000 per pound. And when you consider that most of the mass of any spacecraft you send up is propellant, then the effective cost of a pound of useful steel on your spacecraft can be as much as the cost of a pound of gold. Now, companies like SpaceX and Blue Origin are doing their best to reduce these costs by developing reusable launch vehicles. But what can be done on the other end of things? Well, like I said, most of the cost is from sending up propellant. So clearly the solution is not to send up propellant. There's two ways to do this. Either we can develop spacecraft that don't use physical propellant, like a light sail, which takes advantage of the fact that light carries momentum to be physically pushed by a powerful beam of light. Or we can design spacecraft that can use propellant that we can find in space. I'm interested in this second option. One prime candidate for such a propellant is water, because it's actually abundant on the moon and in asteroids. And one design concept for a thruster that can use water as propellant is called a thermal water rocket. In this idea, water is superheated to produce steam, and that steam is forced out of a rocket nozzle to generate thrust. I've set out to make a small version of one of these, using laser energy as the power source to tie in more closely with the interests of the rest of my group. Now, in my concept, water flows through a series of parallel tubes into a final chamber and then out of an exhaust nozzle. Laser light is incident on these tubes right before they reach the final chamber, and it heats the metal red hot. As water flows into this hot spot, it immediately boils and turns into steam, how it enters the main chamber and out the exhaust nozzle. I've already made a bunch of progress on this. The design and fabrication process has taken place over the last about 3 months. It's involved a lot of thermal modeling to figure out how exactly the thermal energy will transfer from the laser light into the steel tubes and into the water, and how the fluid flow will respond based on that heat transfer. I've also made many revisions, fixing problems each time. The design still isn't perfect though, and I plan to make further revisions in the coming weeks. I also plan to characterize this device by measuring its specific impulse, the rocket equivalent of the miles per gallon on your car. If this device proves to be successful, then we can expect to see larger versions of it propelling our spacecraft across the solar system in the future. It's my dream to help expand the reach of humanity beyond Earth, and I believe that it's this type of work that needs to be done for that to happen. Thank you.